Okay, welcome back to the channel. This is chassis number 3 in the series of 4 for the same person. The first 2 are the 2 videos prior to this one, so if you want to check those out, check those out. But here we have another K7000 25-inch. I have not done anything other than open it up and make sure that's actually what's in here. So let's take a look and see what we can find. Well, we got a cap kit. And here's the note. It just says, blows fuse. Well, that should be easy enough. Like I said last time, it should be easy enough, but we had other issues. I can't recall. It's been a number of days. What was wrong with the last one? The fuse was blowing, but I couldn't get it to power up, so I don't think I was able to duplicate that discrepancy on that one, but this one just says blows fuse. So let's take a look at it. So far we're two for 4 with these chassis for this person. Let's see if we can make it 3 for 4. Well, we got leaves and other stuff floating around out of this thing already. Well, I can tell you problem number 1. It's blowing the fuse because someone put the wrong kind of fuse in it. It's supposed to be a slow blow, and it looks like someone has put in a fast blow. You can see here from the type of, I don't know if this is a fast blow fuse, and it actually says does it say AGL or MDL on this? F15AL 250. 1.5. Wait a minute. Please tell me that's not 15 amps. Holy Lord. F1. Oh, okay, 1.5. F1.5 amp. Well, either way, this is a fast blow, not a slow blow, so that's problem 1. So I'll bet you, if we go through here, it looks like somebody has already capped this. They didn't put the Nichicon in there, or the 105-degree caps. Get out of here. I mean, there's debris all over the place in this thing. But all of the caps have been replaced. Oh my God. Oh my God! I wish I hadn't turned this over. Oh my God. What in tarnation has happened here? Now boy, I say boy, what in tarnation has happened here? Oh my God. Why is this here? I guess I have no idea what this is doing here. That shouldn't be here. I've never seen a cap across there. Wow, this is... It looks like... Oh, and it looks like D10 is missing. Well, no wonder. There's a problem. If we look here, there's 2 open right here. This point and this point. The shutdown diode is missing. I think it's D10. This one here. Not there. Huh. R104 smashed flat. This, holy, I may be in for a treat on this one. Wow. This may be more than I bargained for on this one. Holy cow. Well, I have no idea why these are here. Never seen these before. I mean, it's not going to hurt to leave, your resistors aren't going to hurt anything. It's not going to hurt it to leave those in there. Why these are there, I can't say. This, on the other hand, I have never once ever seen a cap across these 2 posts. But again, it shouldn't hurt anything. I'm not sure why it's there, but my God. This here, I don't even have any idea. No answer. Is this somebody used desoldering braid. Oh, sorry. Fuck. Sorry about that. This is desoldering braid that's been filled with solder. They're using desoldering braid as a jumper. And over here too, underneath all this. Oh my God, this is insane. Criminy Christmas. Well, it's been recapped. I do not know what the... Yeah, these are all 105 degree caps. So I don't think we'll have to recap this. It has absolutely been recapped. I don't see a single original cap on here. Yeah, this has been recapped, so we don't need to use this. That'll cut some of our work down. But, oh my lord, is our width coil frozen? No, it's not. Okay, let's bring it up. It was all the way down, so I hope they don't have width problems. Usually when you come across these and the width coil is all the way jammed down, then it's got a yoke that's not the right reading, or they got some kind of width issue going on. So we'll bring that up to somewhat close to the top and start with there. Oh yikes. D18. There's a bunch of stuff going on down here in D18. I don't know what this is. I don't know what's going on in here. Someone's changed C38. That's not the... Yep, just like I thought. They're having width problems because this is not the original C38. The critical safety cap is still in there, so this guy there. That's the 4-leg one. Yep, because this is an early version, 1986. So, man. So we'll have to replace D10, this guy there. And we will have to go through and do all of our testing and then do the rework under here, because, oh my lord. Some of these you see this extra cap on here. Like I say, having a cap on there isn't going to hurt anything. I'm not sure what's up with these. I think I've come across this before in the past, but I'm not going to worry about these resistors or these resistors or this cap. I'm not going to worry about that. Let's just get it running and then see where we're at. Because, oh my lord, man. The HOT contacts have been butchered. This is probably the worst condition K7000 I've had across the bench in recent memory. Yikes. Oh man. Well, let's get rid of this cap that looks burned up just for the moment. And I'm gonna mark where it was just so I know later. So obviously we had this post here, that's all burned up as part of D18. Our D18 across our coil connection is from this point to this point. I think this was hooked up to a yoke that shorted because it burned up a crater across D18. Let's go ahead and see if we can get rid of this. This is guaranteed 100% a piece of braid. That has, yeah, that trace is gone. Yep, that's a piece of braid. I mean, if it works, it's not stupid, but that's stupid. Gotta use what you gotta use, I guess. There's another piece of braid under here. Let's just remove all of this. Yikes. Let's get my desoldering station going here. we got this thing here, this craziness. Let's work on one thing at a time, I guess. While we're waiting for the desoldering station to fire up, let's just do our testing and see if we have any bad components, and if we don't, then we'll do all of our rework and see where we're at. Someone has replaced IC1. This is absolutely a new IC1. I don't know if they changed it because they were having video problems, or if they tried to change this thinking it was going to fix the blown fuse, but yowza. Okay, so we'll start with our voltage regulator. We should have, was it 180 on these? I think it's 180 on the 25 inch. Okay, our voltage regulator is not shorted, so that's not the problem. Let's see. Yep, okay. Let's make sure none of the other pins are shorted. Yep. Alright. So that's not the problem. Is C38? Is C38 shorted? Nope. C38 is good. This guy here, not shorted. C38 is good. HOT. That is not a normal reading for an HOT. Let's go to another pad here. That is not a normal reading for an HOT. Something is going on there. That's not right. It should be 0.5 voltage drop, not 0.1. That's not correct. I don't know if that's being influenced by another component, so that'll have to come out. Let's check D13 and D14. Okay, I think that's 14. D13 is good. What about R91? I think it's 2 ohms or something like that. 1.2, that's good. Okay. So we got voltage regulator checks good, B plus resistor checks good. Our HOT does not. Let's check our D18. D18 in here. Let's get in here and do this. D18 is good. All right. Let's check R103. Should be 3 ohms. That's good. I have a feeling this was blowing the fuse because somebody was putting the wrong type of fuse in there. You can see how it says SB is slow blow. Someone absolutely put a fast blow in there. But let's check our power diodes. That one's good. That one's good. That one's good. Good. Good and good. Okay. Not sure why that is like that. Well, there's one problem. R105 has come out. You can see here R104 is 105, I'm sorry. R105 is out, and it came right out of the solder joint. There's a nice little hole there. So we got R104 is not installed properly. That could be a problem. Let's just put that back in there, shall we? Okay, that's good for now. We'll hit it when we reflow. Hit it again when we reflow. Okay. That's back in. Okay, R104 is 15 ohms. 13 ohms is what that read. 15 ohms, that's good. Okay. R101 should be 5K. 4K is a bit low, but it's not out of the realm of functionality. 1.8 is R88. Correct. R89 should be 3.9. Trying to get in there with this lead. .9, that is good. And then we have R96 should be what? I think it's 1.8 as well. Yep. And then R97 should be 280. 270, close enough. Well, let's check C36. We should get the 0.5 voltage drop across here to here, and we don't. We get, because you're reading through the HOT circuit. Something is odd there. So it looks like everything in our power circuit is good, except the HOT is a odd reading. So let's pull the HOT out, just see if it's the HOT that's causing the weird reading, or if it's C36 or something else. This should be fun to try and do here. Well, that worked. That is loose. Just cleaning it out real quick. All right, let's bend these up. I guess since the pads are gone, we don't got to take it out of circuit. There's no more pad left here or here, so we can just test it like this. So let's zoom back out and see what we read when it's technically out of circuit here. Yep, it's not the HOT that's causing the weird reading. That's correct. So there is something else. It's this critical safety cap. That's not a reading that you should have across there. So maybe our critical safety cap is the cause of our problem. Let's take it out of circuit. Get out of there. Okay. Get out of there, you jackal. Okay. So there we have it. Now, let's resolder in our HOT and see if we have a decent reading in circuit now. Let's get rid of. Let's try and make this a bit better here. Okay, that's better. Now let's see, let's go to our other, let's go to this pad here. No, I'm sorry. Let's go to this pad here, and this one we should have our 0.5 voltage drop. No, we don't. Huh. So that's, so there you go, something else in the circuit. Look at that, something else in the circuit is causing that. It's not this. Is this shorted? The critical safety cap is not shorted. The two legs will be shorted. Well, which legs? In circuit? Aren't the legs shorted in circuit? There we go, that side is. That's normal. I think that's somewhat normal. Yeah, both sides. So I'm correct. The legs should read shorted because you're reading the same side of the capacitor. Oop. But when you go this way, they should not read shorted. This side to this side. And that one doesn't. And that one doesn't. So our critical safety cap is good. What else in the circuit is, that's not a good reading. Here to here. Okay, so something on this, it could be the flyback. That is not, that right there should read 0.5, like you're reading across a diode, and it doesn't. It's reading, so that's not correct. Huh, it's not C38. So I guess we'll start taking components out until we figure out what's causing that odd reading. Let's start with the flyback. Okay, let's clean this out. Take this. There we go. Let's see if that did anything. Nope, it's not the flyback. That is just peculiar times 10. Alright, so I got the flyback completely out of the circuit. We're going to set this aside. And I'm going to take my neck board and disconnect here. And disconnect here. Now we can put our neck board aside and work a bit easier on this. What in the hell is causing that to read like that? I gotta say, this is a first for me. This one's gonna be fun to try and figure out. Is it this other junk? Is it this other junk on here? I don't think so. There's nothing else that's part of that. I'm just trying to brainstorm here. We checked that one already. We didn't check this one. That's ripped up. That's awesome. There we go. That's what I want. Huh. What is this? What does Q10 read? Q10's okay. That one's okay. That one's okay. Huh, I am stumped here for the moment. Let's get rid of C38. Put it aside. Still not reading. Something is dragging that down. Well, in the interest of not having a 3-hour-long video, let me do some poking around and find what the problem is, and I'll come back and show you what it is, and then we'll fix it, and I'll show you what the solution was. So I'm going to cut away here. I'll find what the problem is. When I come back, we'll show you what it was. Okay, so it's been quite a while since I last left you, and in that time I went through and removed every single component out of the circuit that's related to the HOT, and I could not get it to read properly. It was always 0.14 something instead of 0.46. I just round up to 0.5. Then the normal transistor 0.5 voltage drop on the HOT was not present, and I removed everything, and I could not get it to either read properly or go back to zero. What happened was the HOT was actually grounding out to the frame because the insulator was bad. If we look at the original one, I removed the HOT and put a brand new one in there with a new insulator. And if we look at the old one, you can kind of see how, if we focus, right here it's charred and burned. Because when the screw went through the HOT, it was grounding out the HOT. You can see here how it jumpered down to here. So the insulator was bad, and the insulator was allowing the screw to touch the frame, which arcs to here, which created this. So that was the cause of the odd reading I was getting, was because this was actually grounding itself to the frame. So that was problem number one. So I got that solved by replacing the insulator and replacing the HOT. So now if we look, the HOT is actually reads good. Let's go back out here. Get my meter. Okay, if we go here, 0.45. Other leg, 0.45. And then our critical safety cap should read the same thing. Yep. Okay, so that problem is solved. So then I went through, after finding that, I went through and reinstalled everything that I had removed, and I did a full complete reflow on everything. Cleaned up all of the junk that was done prior. I still have to go through and do all of the flux removal with the alcohol and get it all cleaned up like I should. But for now, yeah, you can see I haven't really done any of that work. But I went through and did all the reflow. I got rid of this giant solder blob of mess and scraped up the traces and removed the components and used the fiberglass pen to clean off the tarnish on the legs and the contacts and the pads, and reworked it the way it should be done. And I also put some component legs here in place of the solder braid that someone had used prior. So all of this is not cleaned up, but the solder work is redone on everything. And I did a full complete reflow on everything and anything that even remotely looked like it needed it. And it turns out that this cap actually does go right here. I thought I went up here across D18, but it actually does go across here. I did some research, and some of the other ones I've done had the cap across here. And as a matter of fact, I've got one here that I was working on that you can see the cap, it's the same cap across the same legs. So I was going to put it back up here across D18. That's where I thought it went, but it actually goes right where it was. So that's correct. I thought someone put that there by accident or mistake, but that's correct. And this resistor here actually goes on the top side. If we look right here, you can see that there's a missing component. That resistor is supposed to be on the top side, but it's okay to have it on the bottom side. And of course I replaced the fuse. And I think that's about it. I mean, after doing, I'm just going to leave these here. As a matter of fact, if you look at these odd resistors here that I thought I wasn't sure if that was a factory mod or not. If we look at this one, it's got the same resistors here. So, and then of course they got the resistor on the bottom side of this one too. So it's like a carbon copy. So I'm glad I had that one as a reference. The only thing it doesn't have is, oh, it does. This is exactly the same. It's got these same resistors here as there, and this capacitor here and there. So these must all be factory mods. I'm not used to seeing these. I'm not used to seeing this capacitor here, or this here, or these there, or these there. This apparently is all factory mods. So hey, that's why it's the amateur channel, because I don't know everything. But I've gone through and done the full complete reflow and inspection and testing, and the only thing we found was the HOT acting weird, and that was because of the shorted base to the frame. So that's been taken care of. So let's get it on a tube and test it and see what we get. So stand by. All right, so we're all hooked up. I'm actually on a K7000 tube out of a Miss Pac-Man Galaga 25th anniversary. So I kind of retrofitted this here to work, but this tube is perfect, known good, and it's got no issues. So if we know there's a problem, it's not going to be a tube issue. So we got everything hooked up: anode, neck, yoke, ground, video, power, and there's no remote board, so we'll count to 6. So yeah, everything should be ready to go. We're going to use our test pattern generator, so hopefully this powers up. And if so, let's see what happens here. We got the test pattern generator turned on. So here we go. The fan's turned off in case something pops or starts smoking. We can see where it's coming from. Otherwise, I think we're ready to go. So 1, 2, 3. Yes, powered right up. The high voltage is rather high. Oh, I can hear the flyback making weird noises. It's like it's cooking bacon in a fryer or in a pan. It's crackling over there. Oh, we got shorted. Oh, yeah, we got a red shorted red transistor or something going on with the red. Oh, and it's, yeah, that flyback's no good. Listen to it. Can you hear that? Sounds like it's frying bacon in a pan. And we got, oh, whoa! Yep. What was that? Oh. Yep. Let's change that flyback, see what kind of results we get with that, because that's the high voltage is too energetic. When I turn it on, the high voltage sounds way too energetic, like it's double, like you're firing up 2 chassis worth of high voltage sound. That's odd. Yeah, well, at least we got it working. It's not blowing the fuse anymore, so now we're gonna have to track down what's causing that flyback to make that odd noise. It's probably the flyback itself. We'll put a new one in there, see what it does. If not, we'll have to figure out something else. Plus, it looked like we had a shorted red transistor on the neck. The pots are all set to center, so it's not an issue with the pots. I don't think they're broken. We can inspect to make sure it's not broken, but it could be a broken pot causing that. We'll inspect that. That's secondary. The red is secondary. Let's just get it working to where it's not making noise and crackling and sparking and whatever the hell that was just doing. So stand by. Alright, so off camera I looked up the part number of that oddball transistor in. It is compatible. It should work. So I don't think that's the problem of my overly red screen. So let's go ahead and turn it on and see what we get now and try and figure out what else is going on here. Oops, sorry. All right, here we go. So it powers right up and is working. It does not start out red. And then that happens. Let's try that again. Let's turn this off. Turn it back on. It does not start out overly red. It's overly blue now. I probably have the pot turned up. But then it gets, see? That is very, I've never seen anything like that happen before. But I think we have all of our colors. If we scroll through here, well, I thought we did. Let's turn our red down a bit. And our green up. Yep, there's our green. So we've got all of our colors. It's just overly red. So the chassis is now working without issue, apparently. No more hissing, no more crackling bacon sounds. Everything seems to be working fine now. So we got the chassis repaired. Now we just got to figure out why we have an overly red image. And I don't think the transistor is shorted because it doesn't start out red immediately. I think there's something wrong on the main board, whether it's one of the 3 transistors right here, 1, 2, 3 for RGB, or IC1 could be bad. Like I say, someone changed it. But we have an overly red image now to try and figure out, and I don't think it's a shorted transistor. And it's absolutely not the tube, so if you're thinking that, it's not the tube, because you can see right here it's not red. That's your first indication that it's not red, or it's not the tube. Something is definitely odd here. If I turn the red knobs completely down, whoa, oh, got a little close there. Yeah, it doesn't seem to make any difference at all. So we'll put those back up a bit. Oh, you know what? I was turning blue, you dummy. That was blue. So right there, the red pots are all the way down. I still have a giant red screen. So there's something wrong on the main chassis here. So let's put all these back to center position. Sorry. Okay, close enough. All right. So we've got all of our colors here. I don't know why we're way out of focus now. I thought I had that fixed. Yeah, it's the screen. Let's go ahead and just turn this off and back on. There we go. Yeah, focus is fine. Wait a minute, that's weird. If I turn it off and back on, that is odd. I'm adjusting contrast right now. I'm going to change IC1. I want to put a different IC1 in there. First, I'm going to check these 3 transistors here. I know it's not the neck board. I don't think it's the neck board because we have all of our colors. We have RGB. All the colors are present. So I don't think it's an issue with the neck board. I also don't think it's an issue with these 3 transistors here now that I think about it, because we have all of our colors. If all 3 of our colors are present, it's not a transistor bad, it's not a resistor bad, it's not a header pin problem, it's not a neck board problem. I think our problem lies in IC1. So let's get IC1 replaced and see if that fixes our problem. Alright, so quite a bit of time has elapsed since I last left you, because this video is already super long, and in the interest of not having a 2-hour-long video, I went ahead and did a bunch of stuff off camera, and I'll show you what I found. So I originally wanted to change IC1, thinking that was the culprit for my mostly red or all red screen. So I changed it out. That's a brand new one, and it did not fix the problem. So I then installed a complete working known good neck board. I swapped out this neck board with the complete known working good one, turned it on, still had the red screen. So at that point, the only thing left in the circuit that I know that could cause something like that would be these transistors. There's Q1, Q2, and Q3 for, you know, RGB respectively. And when I measured these transistors to each other, the blue and the green were identical. From the base to the emitter and the base to the collector, I think it was like 0.643 to emitter and 0.603 to collector. But on Q1, which is for the red, it was, instead of being 0.643 to the emitter, it was like 0.591, and the collector was 0.54 something. So it was reading somewhat close to the other two, but because it wasn't reading the same as the other two, I went ahead and replaced it. I have the original one that I took out right here that reads close to the other two, but not quite the same. So I took this out and put one in from a donor chassis that I know didn't have color issues. That was became a donor chassis for other reasons. So now let's see what we get now. I will turn it on. 1, 2, 3. Actually, you know, I have to turn this on first. Sorry about that. And here we go. All right, fires right up. Sounds good. Works great. And no more red screen. So that was the problem. We had a bad Q1 off of the red input. Okay, so here we go. Final testing time. Everything is adjusted. We have a nice full square image. Colors are good. We have complete width control. So the C38 that they replaced is the correct rating. And everything is working great. So let's do a final test just to show you everything in action. And we'll call this one repaired. Yeah, I got everything hooked up. So here we go. Okay, powered right up. And voila. There you have it. Looks a bit too green on camera, but in person it looks pretty good. Yep. There it is. Maybe a bit too blue. That's better. Okay, that's a lot better. Well, there you go, guys. Quite the head scratcher, but turned out just fine. Another one kept from the junk pile. Yeah, it's hard to really show how good it looks in person. I'm sorry, through the camera, because in person it's much better. Now it looks a bit too blue. In person it looks perfect. I mean, I've been using this board to test monitors and colors for years. So in person it looks a lot better, but you get the idea. It doesn't matter ultimately, like I say every time. It's not going to stay on this tube, so it doesn't matter. But I like to get it looking as best I can just to make sure everything is good. So there you have it. I mean, if we review... Actually, you know what? I'll let it run for a couple of hours. At the end of that time, just to make sure nothing is wrong with it, I'm going to take it back off the chassis. I'm sorry, take the chassis back off the tube, and we'll go through and do a final review of everything. So I'll let this run for 3-4 hours or so until let's see, what time is it? 12:30? Yeah, until about, well, I'll say 5 o'clock. 5 o'clock, I'll take this off if nothing goes wrong, and we'll go over everything and review what we found and what all it took to get this working. So it'll be 4.5 hours for me, but it'll be like this for you. Okay, time for the review. So we had all of the butchery on the back, and we learned that all of these mods are all factory mods. I just hadn't been used to seeing them. So this being on the bottom, these two resistors, this extra capacitor, these two resistors, it's all factory mods. I still need to go through and do the cleanup. I always do that last before I put it back in the box to send back to the owner. So we learned all of that. We got all of our solder rework done. It doesn't look award-winning, but it's functional and it should last a good long while. And There's nothing else really left to say about it. It's all working, so that was all complete. There's a giant hole here and a giant hole here, but you know, like I say, functionally speaking, it's fine. The rework is better than it was, and everything works great. So we can leave it the way it is. After I clean it up, it'll be 100%. The top side, we had the wrong type of fuse installed, so that's most likely why it was blowing, or it also could have been the problem with the HOT being shorted to the frame. So we had the wrong kind of fuse installed. We had the HOT shorting to the frame with the bad insulator. We had, what else? Oh, we had a bad Q1 that was causing an overly red screen. The HOT itself, I think, was faulty, not just shorting to the frame, but it read okay out of circuit, but I think it was actually faulty. I didn't trust it anyway. I thought we had D10 was missing. I got D10 reinstalled. I think I forgot to mention that when I went through the bottom of the board and talked about fixing the HOT and doing the reflow. I think I forgot to mention D10. I replaced D10, so that was missing, got that done. The brightness pot was the wrong rating. This is the pot that was in there. You can see it's a bit rusted, and it's a 200 ohm pot. It's supposed to be a 2000 ohm pot. So someone put a 200 ohm pot in place of a 2K ohm pot, and I had almost no brightness control. So I replaced it with the correct rating of one. It's the wrong type, and it runs backwards. All the way to the right is down, all the way to the left is up. So it'll fool you, but I had to put the right kind, or the right rating in there. And the vertical size pot was also the wrong kind. I mean, technically it worked, but this is the kind that was in there, the kind that if you put a screwdriver down too far into, you can short it out, a metal screwdriver. So I took this out. This was in the vertical size pot location, so I changed that out to the correct kind and the correct rating. So that was done. I thought IC1 was bad for the red screen, but it was actually Q1. So all told here, we had the wrong type of fuse, we had a bad HOT, we had HOT that was shorting to the frame but a bad insulator, we had a bad Q1, we had a wrong brightness pot, we had a wrong vertical size pot, we had a missing D10, and we had a bunch of burned up traces and bad solder work. So, oh, and I almost forgot the most important thing. The flyback was bad. This flyback, when it was in the chassis, was giving out sizzling bacon sound effect, and I don't know what was causing that, but it obviously was bad because I put the new one in there and it doesn't do the sizzling bacon sound. So I think this is internally squeaking and hollering, and I don't know what's going on. So yeah, bad flyback as well. So that pretty much wraps it up. It's already been capped, and I made sure all the cap legs and connections were good on the reflow. So we can officially remove the tape that the owner put on there. Call it successfully repaired. So I hope you learned something. And as always, thanks for watching. Stay tuned for more. One more chassis in this series for this person, and then I'm also getting a shipment of like 5 or 6 more from another person, so those will be coming soon. Stay tuned. And yeah, like, share, and subscribe. I appreciate you watching. Thank you very much.